Okay, guys, one last video. Quadratic formula continued. Now we're actually going to do some examples. First one I want to solve is x squared minus 4x equals -1. I have my quadratic formula here to remind me. And the first thing I want to do is I want to get this thing in standard form so I can use the quadratic formula. Now looking at this, I see that a is 1, the coefficient here. I see that b is -4, the coefficient here, and I see that c is 1. So I'm just going to plug and chug. X equals -b, that's 4, plus or minus the square root of b squared. -4 squared is 16, minus 4 times a times c. All over 2 times a. So what I like to do is I like to break this up into two separate fractions. The first one is 4 over 2, or just 2. Plus or minus, I have square root of 12 over 2. So the question is, am I done? Well, no, I got to fully simplify. I know that this is 2 plus or minus root 4 over root 4 times root 3 over 2. Root 4 is 2. So I can simplify. So altogether, I'm getting 2 plus or minus root 3. So that looks like this. 2 minus the square root of 3 and 2 plus the square root of 3. Now these right here, they're not really easy. We would have had a hard time trying to factor this and find these solutions. Okay, so that's why quadratic formula is very useful in a situation like this. We could do it by completing the square if we had wanted to. Okay. So with this, I want you to notice that these solutions are irrational, meaning I can't write them as a single fraction because I got the square root of 3. That's some number that kind of goes on forever after the decimal 1.73 something. Okay, so keep that in mind. So this is two real irrational solutions. Okay. Down here, if we look at b, x squared equals 2x minus 10, let's do the same thing. So I say, okay, that's probably kind of hard to factor, so I'm going to go ahead and use my quadratic formula. First things first, I'm going to identify a as 1, b is -2, and c is 10. And then I'm going to use my handy-dandy quadratic formula. So if I plug and chug, I'm getting x is equal to -b, which is 2, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. Now here's the interesting thing that happens here is if I split the numerator, I got 2 over 2, that's just 1, plus or minus, I have the square root of 4 minus 40. That's -36. And we know what this means. This means that our solutions are going to be complex. So I'm going to get 1 plus or minus 6i over 2. Hopefully you're okay. You can see how I got from here to here. And I'm going to simplify like so. So I got 1 plus or minus 3i. So I have 1 plus 3i. And I have 1 minus 3i. So now that I'm here, I have no real solutions, right? No real solutions, really just too complex. Because we only call it a real solution if it only has real parts. So I want you to keep that in mind. So now that we've kind of talked about these different types of things, these different types of solutions we're getting, there's one thing I want to point out, and that is something we call the discriminant. Okay, it's this thing right here, b squared minus 4ac. Okay, so b squared minus 4ac is known as the discriminant, and I should probably make it so you can see this, right? Okay, so we're right there. Notice that that thing under the square root, that determines if we're going to have two real solutions, if we're going to have two solutions that are complex, so we get imaginary stuff if it's negative underneath there. And then what if it was 0? Then it would be 2 plus or minus 0 over 2. Then we just have one solution. So this discriminant really tells us a lot about what type of solution we have. And that's really quick to check. If you don't have time to solve the whole thing out, you can at least know what types of solutions you have. Okay? So they outline this on page 120 of your book. Okay? Maybe I can get a little bit closer so we can see a little bit better. So notice what we got here. The discriminant, if it's positive and it's a perfect square. What that means is if it's positive and it's something you know the square root of, like you get like 4, 9, or 16 under the square root, you have two solutions, two real solutions, and they're rational, meaning they don't have any of those square roots that go on forever. If your discriminant is positive but not a perfect square, which we did have that was this part A right here, right? We had a positive, but it wasn't a perfect square. Then we have two solutions still. They're real, but they're irrational, just like we had mentioned. If you have 0 under the square root, we didn't do an example like that, then you have one solution. We call it a double solution. So it'd be something like 2 plus or minus 0 over 2. Well, then the answer is just 2. And it's still rational because there's no square root involved, because that part was 0 underneath there. And then finally, like B we just did, if the discriminant is negative, so you get the negative under the square root, like we did, you have two solutions, but they're non-real complex solutions, right? A plus BI. So be aware of the different types. And just remember, I will require a completing the square on the test. So do know how to do that. Other than that, do it whatever way is easiest. All right. That's the last video for section 1.4.